Stars, they light up the universe, fuel life, and shape galaxies. But how are they born? How do they live? And what happens when they die? Welcome to my channel, everyone. Today, we're exploring the incredible, scientifically proven journey of stars, from their birth in cosmic nurseries to their dramatic deaths as supernovae, black holes, or white dwarfs. This is the story of the life cycle of the universe's giants. Stars are born in vast nebulae, which are giant clouds of gas and dust scattered across the universe. These nebulae are often referred to as stellar nurseries. But what sparks the birth of a star? It all begins with gravity. Over time, regions within the nebula become denser due to random fluctuations in the cloud. This triggers a process where gravity pulls gas and dust inward, forming a dense core known as a protostar. As the protostar contracts, temperatures rise. When the core temperature reaches about 10 million Kelvin, nuclear fusion ignites, turning hydrogen into helium. This fusion releases immense energy, counteracting gravity and stabilizing the young star. At this point, a star is officially born. Once nuclear fusion begins, a star enters the main sequence phase, the longest and most stable part of its life. During this phase, hydrogen is converted into helium in the core, releasing light and heat. The size and temperature of a star determine its characteristics. Small stars like red dwarfs burn their fuel slowly and can live for tens of billions of years. Medium-sized stars like our Sun have lifespans of around 10 billion years. Massive stars like blue giants burn through their fuel quickly, living only a few million years. Stars remain in the main sequence until they exhaust their hydrogen supply. When a star runs out of hydrogen in its core, gravity takes over, compressing the core and causing it to heat up. This triggers the fusion of heavier elements like helium. For small and medium-sized stars, including the Sun, this marks the beginning of the red giant phase. The outer layers expand dramatically, and the star becomes cooler and redder. Eventually, the star sheds its outer layers, creating a stunning planetary nebula. What remains is the core, a small, dense object called a white dwarf, about the size of Earth but with the mass of the Sun. Over billions of years, the white dwarf will cool and fade into a black dwarf. For massive stars, the process is far more dramatic. Once they exhaust their hydrogen, they fuse progressively heavier elements like carbon, oxygen, and silicon. This continues until the core is composed of iron, which cannot undergo fusion to release energy. At this point, the star collapses under its own gravity, triggering a supernova, one of the most powerful explosions in the universe. A single supernova can even outshine an entire galaxy for a brief time. After a supernova, the fate of the star's core depends on its mass. If the core is between 1.4 and 3 times the mass of the Sun, it compresses into a neutron star, a city-sized object with incredible density. A neutron star's gravity is so strong that light bends around it, and its magnetic fields can create pulsars, which emit beams of radiation. On the other hand, if the core is more than 3 times the mass of the Sun, it collapses into a black hole, an object with gravity so intense that not even light can escape. Black holes are among the most mysterious objects in the universe and play a crucial role in shaping galaxies. Stars aren't just celestial objects, they are the universe's engines of creation. Through their lives and deaths, they generate and disperse elements that form planets, moons, and even life itself. For example, the carbon in your body and the oxygen you breathe were forged in stars. When stars die, they recycle these elements into space, seeding future generations of stars and planets. This cosmic recycling connects us all to the stars. To summarize, the life cycle of a star unfolds like this. Birth. Stars form in nebulae when gravity pulls gas and dust together. Main sequence. Stars burn hydrogen, shining brightly for millions to billions of years. Death. Small and medium stars become red giants, then white dwarfs. Massive stars explode in supernovae, leaving behind neutron stars or black holes. This process has been shaping the universe for over 13 billion years, creating everything we see and everything we are. The life and death of stars show us the incredible power, beauty, and interconnectedness of the universe. From their fiery births in nebulae to their explosive deaths as supernovae, stars play a vital role in the cosmic story. What fascinates you most about the life cycle of stars? Let me know in the comments below. And if you want to explore more mysteries of the universe, don't forget to like, subscribe, and hit the bell icon for notifications. Until next time, keep looking up. The universe is waiting.